Hey everyone, and welcome back to Talk Tensors. When we think about building ontologies, it can feel like kind of a pain sometimes,
Yeah.
right? It's all about precision. But to get there, it's so time consuming. And to be honest, even the best engineers, ontology engineers, make
Yeah.
mistakes.
They do.
It happens.
Yeah, it's a real paradox. Ontologies are more important than ever, especially with explainable AI, the rise of things like neurosymbolic integration.
Right.
But the process is a major bottleneck.
So that's what today's paper is all about. It's called Ontology Generation, using large language models by Lipless et al. And it's making waves
Yeah.
because it's suggesting that we might be able to use LLMs
Oh,
to
wow.
automatically generate ontologies, the LLMs that everyone's talking about these days.
It's a pretty bold idea, and the implications could be huge.
Right.
Imagine just feeding your requirements, things like user stories or competency questions,
Yeah.
into an AI
Yeah.
and getting a decent first draft of an OWL ontology.
Okay, so let's back up a bit for anyone who's not, working with ontologies day in and day out.
Sure.
Remind us why this process is so tricky traditionally.
Well, think of it like building a house. You need a blueprint, right?
Yeah.
Well, ontologies are kind of like blueprints for knowledge. They define concepts, relationships, and rules that govern a particular domain.
So to do that well, you need a specific set of expertise.
Exactly. You have to be able to think abstractly, understand the nuances of the domain, and translate all of that into a formal, logical representation, and that's hard.
And there's so much room for error.
Oh, yeah, tons.
And those errors can have ripple effects.
Absolutely.
Right. A flawed ontology, inaccurate inferences, unreliable knowledge graphs, ultimately systems that just don't work.
That's why this paper is so intriguing. It tackles the challenge head-on, explores whether LLMs, which we know they've shown impressive capabilities in natural language processing, code generation,
Yeah.
could offer a more efficient and maybe even more accurate way to generate ontologies.
So it's like asking, can we automate the blueprint creation?
Precisely. And to do that, the authors had to address some pretty fundamental questions.
Like what?
First, can LLMs actually generate ontologies that are aligned with specific requirements? So not just random concepts, but creating something usable.
Ought to be usable.
Right. And it's not just possible in theory. We want to figure out how to do it.
Right.
So they proposed two different methods for using LLMs.
Okay.
Memoryless CQ and OntoGenia.
Now, before we get into those, I think we should probably make sure everyone understands what competency questions are. We call them CQs. It's a bit of a,
Semantic web.
yeah, semantic web insider term.
Good point. Competency questions are basically test questions.
Right.
For your ontology, they help verify if the ontology can accurately represent the knowledge you're trying to capture. So if you're building an ontology about books,
Yeah.
a competency question might be, can this ontology tell me all the books written by a particular author?
So it's like a way to make sure your ontology is, it's doing what it's supposed to do, fit for its purpose.
Exactly. Now back to those methods. The first one, memoryless CQ-CQ, is all about breaking down the task into smaller chunks,
Okay.
more manageable.
So instead of generating the whole ontology at once,
Yeah.
it focuses on one competency question at a time.
Precisely. The LLM is given the ontology story. It's basically a high-level description of what the ontology should cover and a single CQ.
And it's called memoryless because,
Because each time the LLM tackles a new CQ,
yeah,
it does so without any knowledge of what it did before, any of the ontologies it might have generated for previous questions.
okay.
It's like starting fresh each time.
Like a clean slate.
Yeah, so very focused, task-oriented approach.
So it's like you're giving the LLM laser focus.
Exactly. And that has some advantages. By limiting the LLM's context, you might prevent it from getting bogged down in irrelevant info or making inconsistent choices. Simplify the problem, let the LLM's strengths shine through.
Okay, so memoryless CQ is very focused.
The second method, OntoGenia, takes a more holistic approach.
Okay.
Instead of treating each CQ as an isolated task, OntoGenia builds upon what it's already done, incorporates each output into the next prompt.
So it's more of an incremental learning process.
Exactly. This aligns well with how we humans build knowledge.
Right.
We start with basic concepts and gradually layer on complexity.
So the LLM with OntoGenia is constantly refining and expanding its understanding as it goes.
That's the idea, and a few key features make OntoGenia really interesting.
Okay, like what?
First, it uses not only competency questions, but also user stories, those narratives about how the ontology will be used in practice,
Okay.
to provide a richer context.
So it's getting a more complete picture of what the ontology should be doing.
Right, and it also incorporates something called ontology design patterns,
Okay.
ODPs.
ODPs.
These are pre-built templates for common ontology structures.
I see.
It can save a lot of time and ensure consistency.
It's like having a library of reusable components, kind of like software libraries, but for ontologies.
Exactly. But OntoGenia goes a step further.
Okay.
It uses a technique called metacognitive prompting,
Okay.
which encourages the LLM to kind of think about its own thinking.
So it's like the LLM is double checking itself. It's like, am I doing this right?
Exactly. It's a way to introduce that self-awareness into the LLM's decision-making, which could lead to more accurate and robust ontologies.
That's really fascinating. Okay. And then OntoGenia is iterative,
Yeah, it doesn't just generate an ontology all in one shot.
right?
It goes through multiple steps, refines, and improves each time.
So it's not just about speed.
Yeah.
It's about quality.
It aims to produce ontologies that are well aligned with the requirements and structurally sound.
Okay. So we've got these two different methods, both aiming to harness the power of LLMs for ontology generation.
Right.
To see how well they actually work,
Okay.
we got to talk about the data they use, right?
Absolutely. And that's what we'll cover after a short break.
Stay tuned.
All right, so let's talk data. The researchers behind this paper didn't just want to test these methods in a vacuum, right? They wanted to see how they performed on real-world ontology engineering challenges.
So they needed a data set that reflected the kind of, messy, complex requirements that ontology engineers deal with every day. So what did they use?
Yeah, they pulled together a pretty comprehensive data set, drawing from a mix of actual projects and educational materials. They started with 10 base ontologies, each with a set of 10 competency questions. So that's 100 CQs in total.
And where did these ontologies come from? I'm guessing not just some random collection.
You're right. They chose ontologies from established projects like Polyphonia, OntoDecide, and WHOW, all doing some cutting-edge work in areas like cultural heritage and decision support.
So ontologies that have been battle-tested in real-world applications.
Exactly, but they also included ontologies and competency questions developed by students in a semantic web course.
Oh, interesting. Why include the student work?
It provides a good baseline for comparison. Can these LLMs do better than someone just learning the ropes of ontology engineering?
That's a clever way to gauge their performance. And did they just throw all these competency questions at the LLMs without any further categorization?
Not quite. They made sure to include a variety of competency question types, from simple ones focused on defining basic properties to more complex ones involving tricky concepts like reification and restrictions.
Hold on, what exactly is reification? I know it's important, but I always struggle to explain it clearly.
It's one of those concepts that can make your head spin a bit. Essentially, reification is a way to represent statements about statements in your ontology.
So instead of just saying John wrote the book, you might want to say something like Mary believes that John wrote the book, where the belief itself becomes part of the ontology.
Exactly. It adds another layer of complexity, and it's something that traditional ontology engineering methods often struggle with.
Okay, back to the evaluation. They had their data set, they had their methods. How did they actually measure how well the LLMs did?
This is where it gets really interesting. They took a multidimensional approach to evaluation, going beyond just simple accuracy metrics.
Makes sense. An ontology can be technically correct, but still a complete mess to work with.
Precisely. So first, they used a tool called the Ontology Pitfall Scanner, or OPS for short.
Cute name.
Right? OPS checks for common modeling mistakes, like creating redundant classes or violating basic ontology design principles.
So it's like a style guide and a quality control checker rolled into one.
Exactly. Next, they measured what proportion of the competency questions were actually modeled by the LLM-generated ontologies, because it's one thing to create something, but it needs to be something that actually captures the knowledge it's supposed to.
Right. If the ontology can't answer those test questions, it's not very useful no matter how elegant it might look. What else did they look at?
They did a structural analysis focusing on what they call superfluous elements. Basically, anything the LLM added that wasn't strictly necessary to address the competency questions.
So extra classes, properties, relationships, things that clutter up the ontology without adding real value.
Precisely, and this is important because one of the goals of good ontology engineering is conciseness and clarity. We want to avoid unnecessary complexity whenever possible.
It's like writing clean code.
Yeah.
You want it to be efficient and easy to understand, but all of these metrics are still fairly quantitative. Did they have any human experts involved in the evaluation?
They did, and this is crucial because ultimately ontologies are meant to be used and understood by humans. So they had two experienced knowledge engineers independently review the outputs.
To get that qualitative expert perspective.
Exactly. These experts assess the overall quality of the generated ontologies, how usable they were, and whether they truly address those competency questions in a way that made sense.
Okay, they put in the work to get a really thorough picture of the LLM's performance now. For the big reveal, what were the results?
Well, first, the good news. Both methods, memoryless, CQ-CQ and OntoGenia, showed real potential, especially when it came to modeling those single competency questions in isolation.
So for tackling very specific knowledge representation tasks, LLMs could be a real asset. Right.
Exactly. But when it came to overall performance, OntoGenia consistently outperformed memoryless CQ-CQ.
That's interesting. What do you think contributed to OntoGenia's success?
It's likely a combination of factors: the incremental learning approach, the use of user stories and ODPs to provide richer context. All of these likely played a role.
It seems like giving the LLM more information and encouraging it to build on its knowledge as it goes really paid off.
That's a key takeaway for sure. But within OntoGenia, they tested several different LLMs, and one emerged as the clear winner, OpenAI's O1 preview model.
Yes, OpenAI always pushing the boundaries, what made O1 preview so effective for this task.
It's hard to say for sure without peering into the black box of the model itself, but it seems like O1 Preview has a particularly strong grasp of the nuances of ontology engineering. It was able to generate ontologies that were not only accurate, but also structurally sound and well aligned with the requirements.
So a promising sign that these models are becoming more sophisticated and capable, but were there any limitations?
There were. One recurring issue was the inclusion of those superfluous elements we talked about earlier. Even the best performing LLM sometimes added unnecessary classes or properties, making the ontologies more complex than they needed to be.
So there's still room for improvement in terms of conciseness and efficiency.
Definitely. And all of the methods struggled with the more complex competency questions, particularly those involving reification and restrictions.
So the LLMs still haven't quite cracked those tougher knowledge representation nuts.
Not yet, but remember, this is still early days in the world of LLM-powered ontology generation. These results, both the successes and the limitations, give us valuable insights into how to push the field forward.
And that's where our Novel Notions segment comes in.
Exactly. Let's move beyond what this paper explored and speculate a bit about what the future might hold.
Let's do it. I'm ready to get those creative juices flowing.
Oh, okay.
So we've seen what these LLMs can do, where they excel and where they still fall short. Now let's put on our futurology hats for our Novel Notions segment.
I love this part-time to get a bit speculative.
Exactly. So the paper focused on generating ontologies from scratch. But what if we could use LLMs to help us refine existing ontologies?
That's a fantastic idea. Think about it. Many organizations already have ontologies that have been, painstakingly developed over years.
Right.
But as their needs evolve, those ontologies might need to be updated or expanded.
And doing that manually can be a huge undertaking.
Right. Imagine feeding your existing ontology and a set of new requirements into an LLM. It could analyze the current structure, identify areas that need to be modified, and even suggest potential additions or revisions.
It'd be like having an AI-powered ontology consultant.
Precisely. And it could help us address some of the limitations we saw in the paper, for example. Remember how those superfluous elements were a recurring issue?
Yeah, those extra bits that added complexity without real value.
What if we could train an LLM to specifically identify and prune those superfluous elements, making the ontology more concise and efficient?
So it's like an AI-powered ontology editor cleaning up our messy drafts and making them publication ready.
I like the way you think, and we could even go a step further. What if we could use LLMs to help us translate ontologies from one formal language to another?
So instead of having to manually convert an LML ontology, you'd say RDF or SHACL, we could have an LLM do the heavy lifting.
Exactly. This could be incredibly valuable for interoperability, allowing different systems to share and understand knowledge more easily.
It would break down those knowledge silos that often plague different domains. These are some really exciting possibilities. But I have to ask, what about the potential downsides?
That's an important question. We have to be mindful of the potential risks as well. For example, relying too heavily on LLMs for ontology development could lead to a decrease in human expertise over time.
Right, so it's crucial that we use these tools to augment human capabilities, not replace them entirely.
Absolutely. We also need to be careful about bias. LLMs are trained on massive data sets, and if those data sets contain biases, those biases can be reflected in the ontologies they generate.
It's like the old saying, garbage in, garbage out.
Exactly. We need to ensure that the data we use to train these LLMs is diverse, representative, and free from harmful biases.
It's a responsibility we can't take lightly. But despite the potential challenges, I'm still incredibly optimistic about the future of LLMs in ontology engineering.
Me too. This paper has opened up a whole new world of possibilities, and I can't wait to see what the next breakthroughs will be.
Well, there you have it, folks. We've explored the potential of LLMs to revolutionize ontology generation, from the nuts and bolts of the methods to some far-out novel notions.
And the key takeaway, LLMs offer a powerful new tool for ontology engineering, but like any tool, they need to be used thoughtfully and responsibly.
We need to be aware of both their strengths and their limitations, and we need to continue to push the boundaries of what's possible while ensuring that human expertise remains at the heart of the process.
So what do you think? What other applications of LLMs in ontology engineering can you imagine? Head over to our website or social media and let us know.
And be sure to check out the show notes for a link to the paper. It's definitely worth a read for anyone interested in the future of knowledge representation.
Thanks for joining us on this deep dive. Until next time, keep learning, keep exploring, and keep those neurons firing.
And keep those tensors talking.